Hello, everybody, and welcome to the Wednesday, December 7th, 2016 meeting of SIG Service Catalog. Today, we're going to be talking about unbind and all of the nitty-gritty details that we can get our clammy, cold, but somehow wet hands on regarding unbind. So I'm going to point this at the board. You're actually not in the way, Ben, but that's all right. So now my question to the group is, where would we like to pick this up? I think we had started talking about this in a prior week. Should I draw the whole picture on the board again, or should we shorthand it and pick it up from you've got a binding and talk about what unbind is?
I'm fine picking up. We have a binding.
Yeah, we have a binding. Let's go from there.
All right, so let me see. So I'm going to draw a really small. Can people see this on the board?
Yep, just look a little lower.
Okay. So here's cube. Here's service catalog. We've got a broker, an instance, or I'm sorry. Can you hear me when I'm pointing at the board?
Yeah, it works.
All right. Doug's signaling about 51% agreement. We've got a broker, we've got service class, instance, and binding. Binding is manifested into cube with, let's call it service and a secret for now. Since core does not yet have service injection policy. Everybody level set on this picture?
Sounds good.
Okay.
All good.
Okay. So what, oh, and it's Paul Weil. Hello, Paul Weil. How are you? So now that we have this binding resource, the typical way, the precedent in Kubernetes along indicating that you no longer want to use something is you delete it. And since we can't, we have to ensure that after the API server has gotten that delete request, that we still have something to reconcile on. We have this pattern in Kubernetes called finalization. And what it means is basically that the API server accepts a delete request. And I actually, here's where I realize now that what I have written on GitHub on this is imperfect. Forget what is written on GitHub, and I will just tell you now, I think finalization, and anybody that can correct me on this, please do so now, is driven off the presence of a deletion timestamp on an object. So what this means is basically it gives us a chance to do some other actions before the delete is completed. And the pattern goes like this. So there's me, looks just like me. I'm the service consumer. And I make a delete request against my binding. So API server, REST API gives back a 202 accepted. So I get back an accepted, and what happens inside the API server is that the REST API for this puts the deletion timestamp on the object, but doesn't actually delete it. So I'm just going to put a little asterisk here to indicate that that's been changed. I'm going to widen this just a little bit. So we know controllers in here too. And the controller gets a watch event for this and says, aha, the deletion timestamp is set. I need to go and finalize this resource. But before we talk about what finalization means here, like what actions we take, I want to call out the reason that we do this finalization pattern this way instead of just deleting the resource and relying on controller observing a watch event is that like we have to assume that watch event channel is lossy and assume that we're going to miss events. And without getting into too much detail on the subject, this is why controllers in Kubernetes, in addition to the watch events that they get from the API server, also have a periodic sync loop where they reconcile the entire state of the world. And it's because you might miss a watch event. In fact, the Kubernetes watch API implementation terminates HTTP connections after, I think it's 5 minutes. And you will not get a long-lived watch. You just won't. You'll have it terminated by the API server, have to reestablish it. So you can always miss watch events, and that's why you have to do a periodic relist and sync. Before we move forward, any questions about that?
Does the relist, does it just list the current state of the world, or does it replay all the events from a certain point in time?
It doesn't replay events. It does a list of the entire resource that you watch.
Got it. Okay, thank you.
Filtered by your list options that you have used to establish the watch.
Okay, and it's up to the controller's job to figure out how to make those two in sync. There's no helper there. It's just you're on your own, basically, right?
Right, and the pattern that most controllers have for this, when I say most, I can't think of one that doesn't work like this, but maybe the people in the room that I'm at can think of one, and then I'll look really stupid, stupider, is the implementation pattern for this is that you have a compilation of unit, like a method that that reconciles a single thing, like brings its status into alignment with its spec or takes the next action required to do so. And so with a watch event, you call that thing on the object you got the event for. When you do a resync or relist, you just call that on everything that you got.
Yep, okay, makes sense. Thank you.
Yep. All right, any other questions on that before we talk nitty-gritty details?
I guess just to clarifying, I thought there was a way, and maybe you said this in different words, but I thought there was a way to go and specify like a version stamp or something like that. So when you do a list, you get back like a version or something like that. And then when you call watches, you would be able to say, okay, give me any new events after this point.
There is, and so the field you're thinking of is called resource version.
Yeah.
And it's a monotonically increasing counter basically across all of the API. And what you can do is you can window your watch that way, so you can establish the event that you start getting watches from. But even then, I think there is a deep distrust within the Kubernetes community of such mechanisms. And so I have found that the relist and initial list, like the pattern is list and watch, and you just keep relisting and rewatching, that you just relist the entire thing, if that makes sense.
Mm-hmm. Yep.
We've seen that if you start a watch from a resource version that's too old, you won't get all the watch events since that. I believe it's because of the events cache has been it's been partially evicted, and I think it's because they use an LRU mechanism. But don't quote me on that because I looked at it last week, and that feels like 3 years ago.
If you do a watch that's old enough, you'll actually get rejected and it won't even open the watch.
That's great to know. Thank you.
Okay, so the continuing down the path of discussion about finalization. So there's one major thing that we've already covered the territory, but we didn't call it out, is that in order to implement this, you need control over the REST implementation of the resource that you want to do finalization on. And this is where we get back into, like, there is a need to have our own API server so we can control these details. There is finalization for TPRs, but correct me if I'm wrong. I think we have folks within the group that have tried using that and found that it varies. That facet of TPR is one that varies widely in quality along different versions of Kubernetes. I think the Deus guys have tried TPR finalization. Is that right, Kent, Aaron?
Yeah, we tried it and we had mixed results.
Okay. So I'm going to call out that this is one motivating factor towards having our own API server implementation that we control, that we know to work correctly, and an argument for moving off of TPR basically as soon as possible. How did folks feel about that?
I wanted to add one thing about a TPR-based implementation, and that would be that a user that wanted to unbind would have to not do a kubectl delete, but instead would have to basically do a kubectl edit and add the deletion timestamp and potentially a list of finalizers if that's the way we're going to go. So it's a little bit non-intuitive to do a unbind operation but not do a kubectl delete on that TPR.
Mm-hmm. So that's another good motivating factor, is that the experience is far more intuitive if you just make the REST API for the resource operate like this. So any comments on that before we move on and I talk about what has to happen as part of unbind? It's actually pretty simple. We might find that we can get through this like pretty quickly if we have no questions and start talking about deprovision. Excuse me. All right. I'm hearing nothing. So now the delete request has been issued. It's been accepted. The pattern for finalization is that there is a list of finalizers, and in namespaces, which is where this pattern was introduced, there is a list in the spec, and I think there might be I started making a pull request to add that to the binding and instance resources, but I was enlightened and made aware of the fact that there's now a object meta based mechanism that's just part of the object meta resource or object meta API type that we can use for this. But the crux of it is that there's a list of finalizers, and as those finalizers act, they remove themselves from the list, and the final delete happens is only acted on, and the resource is only deleted after that list is empty.
How are the finalizers stored in the list? In other words, how are they identified?
Very good question, Doug. So The way that that works in Kubernetes is that there is an admission controller that adds a finalizer to namespaces. And I believe actually, I'm sorry, in Kubernetes, one of the defaults for namespaces is to add the finalizer. I believe for other resource types that use finalization, there are also defaults that add them. In systems that consume Kubernetes and layer on top of it, like OpenShift, there are admission controllers that add things to that list of finalizers. So the finalizers are known in advance, basically at creation time, via those two mechanisms, defaults and admission controllers.
That's good information, but that's not quite what I asked. I was wondering if I were to actually look at the resource itself, what does that list of finalizers look like? Are they identified by name, some ID? How are they actually stored in the resource?
They're stored as a list of names.
Okay, so they're just names that are known to the controller, I guess.
Yes, they're names that are significant to the things that are going to process them.
Got it, okay.
So Aaron, I see you put a link into the chat. Do you want to like share your screen and we can look at it really quick? Do you think it's productive to do so?
Sure, it's pretty small, but I can certainly go do that.
Okay.
Let me figure out how software works. Okay. Can everybody see that?
Yep.
Yep.
Okay, so this is obviously a snippet from a manifest file taken roughly from the TPR finalizers examples that Kent and I basically hacked up and found that they didn't work for TPRs. So the list here, finalizers, is what we manually, kubectl created the list with something.deis.io/a and /b. But we also noticed, as Paul said, that some admission controllers will add the Kubernetes default value, and I think there are others as well. So as we went, we would kubectl edit the TPR, take off this one, and it would still be there. And then after we took this one out, the thing would be deleted. And the deletion timestamp would stay static throughout the entire process from when we initially kubectl deleted until we removed the final element in this list of finalizers, at which point, of course, the thing would cease to exist.
Now, just a sort of a question of the Kube way or best practices. Earlier, I said that these names are known to the controller, but Paul, your answer didn't necessarily use the word controller. You used the phrase like, whatever is going to process that needs to understand it. So is it normal for Kubernetes to have like finalized controllers that watch these things, or is it actually part of the controller in most cases?
So the reason that I said the things that process them is that like in OpenShift, there's the Kubernetes level controller that does some parts of namespace finalization, and then there's an OpenShift level controller that does like parts of namespace finalization that Kubernetes necessarily doesn't know about because we have other resources.
Got it.
So in this case, I think it will be sufficient to have a single finalizer that the controller implements.
Yep, okay, that makes sense.
I answered it from a more generic standpoint.
Okay, nope, that makes perfect sense. And is it correct to assume that it really is usually the resources controller that does the final deletion of the resource itself? So he's the one that detects all the other finalizers are gone? Or have you seen cases where some other controller is actually responsible for that?
I believe it varies. And I think in this case, it's sufficient just that our controller do it. I need to think through additional possibilities that I haven't bothered thinking through because I tend to think based on what the next thing is based on what the group has accepted, and I just haven't gotten that far.
Okay, that's fine. I was just curious. Okay.
I'm gonna stop sharing now.
Okay.
Cool.
Okay, so in this case, what the finalizer will do is it will go and delete the resources that have been created in Kubernetes. So it'll do two things. And I'm not sure about the ordering of them. Perhaps we can get some ideas floating around. But fundamentally, there's two categories of things that have to happen. The binding has to be unbound at the broker level. So the broker's unbind endpoint, or I think it's just a delete on the binding endpoint, has to be made. And then the resources that have been materialized in Kubernetes, like secrets, services, service injection policy, anything that we created in Kubernetes from this has to itself be deleted. And then we can delete the binding, do the final deletion on the binding. Any reactions to that?
Makes perfect sense.
Okay. So if this makes perfect sense, I think there's two ways that we can go.
So Paul, I wanted to add one piece.
Sure.
So ordering notwithstanding, I haven't thought through the ordering, but at some point before the real delete happens, I think we'll need to remove the last finalizer from the list, and then let the thing that's watching the list of finalizers do the delete, the real delete.
Yeah, I think that is accurate. That is totally accurate. I just didn't go into that level of detail.
Got it. Okay, sorry.
So, we might decide that since there are categorically two types of things that have to happen, that we can make two different finalizers. We can have a Kubernetes core finalizer and a broker API finalizer that both have to run. But Aaron is exactly right. As actors in the system implement these finalizers, they need to, the pattern is you do your work and then you take your name out of the list. And then, so here's where we get into a point of uncertainty for me, because in Kubernetes Core API, there is a facility in the generic REST update implementation, which appears to implement a behavior optionally that if an update makes the finalizers list empty, that it becomes a delete. However, I have a counterexample to this, which is that the shoot, I've crossed the streams. I have crossed the streams. Never mind.
So just to make sure I understand this correctly, it seems like finalizers is just the standard place to put dependencies, but you don't really get any help from Kubernetes to actually delete them. Is that correct?
Can you define help in this case, Vile?
Well, meaning that if Kubernetes, for example, saw that there is, let's say that we create a secret. Okay, let's say the only thing that we have is a secret. Mm-hmm. If I put a secret in there and ask Kubernetes to delete this object by setting a timestamp, the one behavior could be that Kubernetes looks at it and says, OMG, this object needs to be deleted and it's dependent on this other object. I can delete that object, and then, you know, by recursion, it could basically delete whatever that depends if it needs to delete that.
I feel like there's some conflation happening in your example, and let me just pick it apart. So the Kubernetes resource you're talking about is secret, right?
Sure. let's just say we have a binding, and the only thing that we have in a binding is the finalizer.
Yeah. So we delete the binding, we get a 202 back, deletion timestamp set on binding, controller sees this, controller goes and say for this example, it does the the unbind at the broker level, and then pop a frame off the stack. There's two things in the finalizers list. There's broker finalize and Kubernetes core finalize. Broker finalizer does the unbind of the broker, updates that to take its name out of the list. And when I say broker finalizer, I mean controller. And then distracted. Then the controller goes to finalize, implement the Kubernetes core finalizer. It deletes the secret and say that the secret is just deleted, which I don't think there's any finalization on secrets at this moment. So secret just gets deleted, and then controller can take that Kubernetes core finalizer out of the list and do the final delete. Does that clarify things?
Maybe. Let's just keep going.
Okay.
So Paul, I have a question for you, and if it's too low level of detail at this point in time, just stop me, but I am kind of curious about how people have implemented this in the past. Do people normally have the controller watching the resource, they notice the delete, and then what they'll do is they'll look at, obviously delete timestamp is set, and say they've noticed there are 3 finalizers there. Is it basically just a switch statement that says, okay, there are 3 finalizers, therefore I'm going to go off and asynchronously, or potentially asynchronously, take some action. And then the controller is kind of out of the picture. And then when that finally gets removed, another watch event happens. And this time it'll say, oh, there's only 2 finalizers. So my switch statement jumps to a different spot. And now I'm going to take this other action. Or is there some other pattern that we should be aware of? So
I think that generally a controller only implements a single finalizer. So, and I would have to look at the implementation of namespaces for this, but I believe that what namespaces do is that the Kubernetes core controller waits for all other finalizers to be out of the list before it takes action.
That would imply then that they have different controllers per finalizer.
Yes, that's true. So going back to the namespace implementation, in OpenShift, we have other resources that have to be finalized to fully delete a namespace. So I believe the behavior is that the namespace controller is like, I'm gonna let everybody else go first, and when it's just me, then I'm gonna do my thing. And during the everybody else goes first phase, there's a controller in OpenShift that is watching the namespace resource and saying, I need to finalize this thing now. I'm going to go and delete all the OpenShift specific names, OpenShift specific resources, and then I'm going to take the OpenShift finalizer out of the list, after which in the context of OpenShift, the only one left is the core finalizer, and then the core namespace controller acts. Does that make sense?
Yeah, it does. Okay, thank you.
But that means there's intelligence built into each finalizer to say, I know that I shouldn't do anything until it's my turn.
Yeah.
Knowing when it's turn.
Mm-hmm. Yes, that is accurate.
But that is a model where each finalizer has its own controller, right?
It is, and I think in this case that if we decided to split this activity up into multiple finalizers, which seems to me at this point to be the right thing to do, that we need to build intelligence into the controller to say, I need to do this finalization first, and I need to wait on this other one until it's time to do that one.
Right, but I think that then goes back to the model I originally described, which was more like a watch, right? And the controller just says, oh, okay, I noticed a change. Deletion timestamp is set. How many controllers are left? That tells me basically what I'm going to do next.
Yeah, I think so.
Okay, cool.
Okay. So if we have no dissent on this, I think that there are two. I'll be honest, we got further than I anticipated than we would be at this point. We can talk about deprovision next, which might be a good thing to do, or we can talk about some aspects of API server. My gut leans toward let's talk about deprovision, because if we all understand finalizer pattern, deprovision has some other other details like cascading deletes that we should talk.
I vote for deprovision.
Okay. All right, so let's talk deprovision. Let's rewind the clock. And the clock is now rewound to, we've got an instance that's provisioned and we've got n number of bindings to it. And let's talk about the messy situation where you want to deprovision an instance that has active bindings. So the flow is the same in the sense of service consumer does a delete on the instance. It gets back a 202. Thing gets updated in etcd with deletion timestamp set. Controller sees this either by watch event or relist, goes to act on it. What I wonder from the group is what are people's feelings on cascading delete? And I will say, as I ask that question, that and maybe Brennan, you can answer this. The Cloud Foundry docs on the current API are a bit ambiguous on the subject. I've read both that it is not allowed to deprovision an instance that has bindings against it, and that if you deprovision an instance, there may be orphaned bindings. So, Brennan, can you disambiguate that for us? That's on my lengthy list of questions to ask, but that I have not had time to get to.
I don't actually know the answer to that question concretely. That seems like a question we should talk to Shannon about maybe in the other meeting.
Yeah. So I think the right behavior is to do a cascading delete, because it sounds to me like if I've deprovisioned an instance of a service class, that I should not expect the manifestations of bindings that may be orphaned to still work. I don't want to leave them around if they're not going to work.
Well, obviously, but it seems to me that we should walk through that scenario of a cascading delete, because worst case scenario, Shannon comes back and says, no, we don't allow you to do the delete. And so, okay, we just ban it. But at least we've gone through the discussion of what it means in Kubernetes to do a cascading delete.
Yeah, so in this case, I'm thinking it's another finalizer.
Are bindings owned by the same person who owns the instance?
Not necessarily.
Yeah, so I don't know. It seems like there should be, well, I don't know if you're trying to map to what Cloud Foundry does, but
not necessarily.
We're
trying to do the thing that makes sense in Kubernetes.
It seems like you need both. You need a default state of, if I try and delete this and there are bindings, you get rejected. And then you have to explicitly say, yeah, I want to delete this, and either orphan the bindings or delete the bindings. But the default state should not be I delete an instance and blow away other people's stuff. or orphan other people's stuff.
Okay. So,
In my opinion.
Which means if you try to delete it and it can't because there are dependencies, it needs to return an error code that is explaining why that is happening.
yeah. So we have.
You do the no, I mean it force.
Is that a vote from you for reject it if there's active bindings?
I agree with them.
Okay, so we have 2 votes in the room that I'm in towards rejecting if there are active bindings. I do think that doing that validation is inherently racy, right? So you do need finalization anyway, even if you reject it.
Are you saying you're going to do some sort of finalization when you reject a delete request?
Well, what I'm saying is that, like, say that we implement a validation on deletions for instances that says if I do a list and there are any bindings that target this instance, that I should reject the delete request. All right? If we do that, such things are inherently racy and impossible to ensure that they're like high fidelity. So the race is like you do the validation in between the time that you say, my validation is done, and I actually go and delete the thing, another binding comes in.
Well, you can work around that, right? Because you can mark it for deletion, which prevents anybody from creating new bindings, then requery that there are no bindings, and then delete it.
Okay. I'm hearing arguments towards me being wrong.
Well, either way, I understand the problem of things being racy, but I thought what you were saying earlier was if you detect there are bindings there, we're going to reject the delete request. And I thought you said, even in that case, there are finalizers that are going to be run. Did I mishear you?
Yes, but I might be wrong. So maybe we should forget about that.
I don't think there's any comments around there, but again, there's really multiple delete verbs here, right? There is the safe delete, which is going to get rejected if there are bindings, and then there is the cascading delete, which is delete and tear down bindings that are associated with it.
I assume these are the same API and one of them has a force flag.
Sure.
Well, you could make delete be a soft delete, and then it actually does go away when all the bindings vanish.
That was my understanding too that was my assumption of where we were going here. So all was returned 202 accepted with the understanding that the instance has been marked for finalization, and where finalization is defined as complete when all of the bindings have been deleted, but not necessarily cascading delete those bindings.
So I don't like a soft delete from the perspective of someone that is trying to delete this thing. Because if I really need it to be deleted, I'm okay with it coming back and saying, hey, other people are using this. Are you really sure you want to delete it? And then I have to say, I really mean it. I need this thing to be gone. Whereas if you do the soft delete, it's up to consumers of your thing to go clean themselves up, and then you will be able to be deleted. It puts you, the person, so put it this way. So let's say I'm running in a paid tier. I'm paying for these services to run, and then other people are consuming them. If suddenly I'm out of money, I've got to shut this thing down. I'm not allowed to actually shut it down until other people go do the right thing. It's not a good situation to be in.
Yeah, that's fair.
Yeah, I also like the -F flag.
My concern on the other end, though, is there's a team of 30 and 15 of them are bound to the instance, and I'm the 16th person doing the -F, and now I just blew away 15 people's app's ability to run. So maybe there is just -F and not -F. Again, like you said, I don't know who said that just now, but having -F be, this is serious shit. So know what you're doing.
Yeah, that's me, delay. I like the F flag or dash dash. Please let me do what I want to do right now.
I want to call it F flag.
So I think something that would be important to understand here is let's find out for the record what behaviors Cloud Foundry implements. I do not necessarily think that we have to do the same thing, but I would be curious to know from folks that have already wrestled with this problem where they settled. Now, Ben, you're making a list on the board. You want to share that with the group?
I'm just trying to list all the options that I'm hearing so far. So I think I've heard fail if bound with an additional, you can force cascade deletion to happen. I heard soft delete, which basically marks the service as essentially sort of deprecated, and then you kind of wait for all the bindings to go away and then finally delete the instance. There was always cascade, which would be, there's just one, when you delete the instance, all the bindings always go away. I feel like there was another one, but now I'm not able to come up with what it was.
Eject the warp core.
It was along the lines of another option of what to do if it was already bound. But anyway, I feel like we can pretty clearly reject the always cascade. Like, I don't think that's ever going to be the viable path without an option.
Yeah.
It is very negative. I don't know I'm breaking people.
Yeah, something cascading I think needs to be behind a flag that says, I know what I'm doing.
But were there any other behaviors that either people had suggested or are thinking of now that they don't feel are listed?
I'm not hearing any. Okay, so I think this one is settling on somewhere between force and, I think what it's settling on for now is fail if there are active bindings with the option to do a force in cascade. And I don't think anybody likes always cascade.
Again, the problem I have with the soft delete is my quota is still being affected, right? So unless there's some way that you can say this thing's been soft deleted and have the things it created no longer affect my quota.
It sounds like do not want.
Well, but wait a minute. Is that true? Because the bindings are owned by the person who's running the app, right? Which may not necessarily be in the same namespace as the instance. So it depends on how far the delete goes. If the delete doesn't actually delete the bindings right away, but it deletes other stuff,
I think your point about quota, Jessica, was quota of
The person running the
instances.
service, yeah.
The instance, the quota of the instance is consuming. But you could combine soft delete also with a force, right? Again, where the default is soft delete and waits until the bindings go away, and you could still have a forced cascade in conjunction with this for Jessica's case of I need this thing gone right away.
It is an option. How do I know there are things that are using it if those things are in other namespaces? Whereas the fail,
Are you not, as the
immediately
owner of an
know.
instance, are you not going to know if people have bound to your thing?
If I mean there are other namespaces I don't have access to.
Well, I didn't know if we would be registering metadata at the instance saying this thing is in use by like references.
We have not explored cross namespace bindings in detail yet. We have received an edict from Brian Grant. They must be possible.
They must be possible, but you can't expose the names of other namespaces you can't see. So the best you could do is say, yes, this thing.
I was going to say, even if it is a ref count of this is in use.
Sure, it could have a ref count, and then that would solve that problem.
So are you guys saying, I don't know everyone's name in that room, apologies, so I'm going to refer to you guys as you guys for now. So you guys saying there's a requirement to do hard delete everything immediately, and deprovision, but there's also a requirement to effectively, like you said, someone there said, have a ref count so you can tell who you're forcing to delete bindings of. Is that what I'm hearing?
The idea behind the ref count was more, if we were down the path of doing a soft delete with a cascade option, then somebody who's invoking that soft delete doesn't have a way to know if the instance is going to go away right away or not, unless they can look at the instance and tell if it's in use.
I see. So do you guys also then believe that you need to know where the bindings are? For example, what apps are currently bound and they're causing this delete?
You can't, because it's going to leak information across namespaces.
So we have not, I don't know how to reconcile that with the fact that we haven't really figured out how to even bind across namespaces though.
Yeah, I think
Just conceptually, assume that it's possible.
So I think that we should settle on a for now that is considering these things with the plan in mind that once we feel like the happy path basics are agreed enough to and perhaps implemented and stable to a degree that we can come back and start talking cross namespace bindings, that we can reassess then.
Yeah, because that's really nasty, because if you have no way to know who's using it and you just know somebody is using it, then the -f flag is very, very dangerous.
Yeah, I think we have to assume there has to be some way to get some information to at least notify someone else that their instance is about to be deleted. I understand the security concern, but if that security concern is that real, then you probably wouldn't let them link to your instance anyway. You have to, as an owner of an instance, I have to be able to know who's using my instance.
Yeah, I think in both the -f and the cascade, the -f and the soft delete, as the operator, you either have to tell people or you have to know who you're affecting.
Especially when, as the owner of the instance, I'm the one paying the bill for the usage of it. I have to be able to know who's hooking up to it and probably at some point control who can hook up to it.
Yes.
Agree.
Okay, so can we formalize this agreement to fail if bound and force cascade for now, with option to reassess later, as we add additional use cases for cross namespace binding, et cetera, et cetera, et cetera.
I mean, frankly, although it is probably not the right answer to say we can just have all the options, but these are not mutually exclusive. You could have all three of those be options together, right? You can say, I want to fail if it's bound, I want to mark it for soft deletion, and I want to be able to force cascade. So you don't have to make this decision now. They should probably all be considered on the table. I don't know that you're going to have a good user experience if all of them end up being options in the final thing.
Yeah, I would prefer to have like Pareto 80% in simplicity and implementation and explanation over infinite flexibility.
Fail if bound plus force cascade probably gets you 90%. And somebody who wants to be able to do the mark this deprecated and then eventually get rid of it, they can do that through manual processes. Right?
Mm-hmm. Okay, so it occurs to me that I don't think anybody has been taking notes through this. Yeah, we can do that, but we also like to put notes in our agenda to show what we agreed to. So in the few remaining minutes that we have left, I'm going to say on unbind that group agreed or discussed flow for finalization based unbind and deletion timestamp set on first delete request controller manages or controller handles two facets of unbind finalization. Those are broker unbind and then deletion of core resources. And that we called out need for control over REST API implementation for resources to be finalized. Deus noted that TPR finalization has significant issues across versions of Cube. And then for deprovision, that we discussed a similar finalization-based deprovision and did not, many cases remaining to discuss about cross namespace bindings. For now, consensus is that is for validation of no existing bindings to instance with an option to force delete and cascade. Call out that cascade across namespaces is hard/impossible to do.
So can you elaborate on the cascade? In particular, when it bubbles all the way down to the secrets and maps, do they get deleted immediately? And how does that affect any pod that has them mounted? So
to me, cascade from instance level means your bindings get deleted. Normal unbind happens for those. So really, this is not an aspect of deprovision. It's an aspect of unbind, right? So what happens when you unbind and you have a pod that's using a secret is, and this is just based on my understanding, which actually I had a user complaining to me about this yesterday, and so I think there may be a bug that we go fix. What should happen is like so there's a few different layers, right? Just from a pod standpoint, it means that the next time the eventually consistent volume plugin goes to run, it'll say, oh crap, I can't get the secret, so I'm gonna bail out. And you're kind of left with where you're at. For environment, secrets that are consumed in a pod's environment, we have no mechanisms in place to update those pods based on anything that happens to the secret, so nothing happens. I think that, at like the deployment level, it might mean that you redeploy.
I think I understand that little, but I wasn't sure on what you just said is, let's remove everything that we're doing from the picture. Let's say I have a pod and I have a secret mounted into there. Mm-hmm. If I delete the secret, am I allowed to? And what happens to that pod, assuming it's not been restarted? It's still running. Is the volume no longer accessible to me? What happens?
So if you delete the secret, you are allowed to.
Okay.
The pod keeps running. The volume remains accessible with the last state that was projected into it of the secret. So
it's almost like a soft delete on the secret.
Well, it's a delete and the thing stops working, presumably, right?
Can I read from that mount?
You can still read from it, yeah.
So from a volume perspective, it is still there. It's like a soft delete.
I don't know what you mean exactly by soft delete in order to say yes or no.
Okay. Well, if the volume is still readable, then something still knows about it and keeps it there. So I'm assuming that if the pod was to get restarted, that's when that volume mount would actually vanish and get cleaned up.
Remember, pods are immutable. Pods do not change. So let this be the cliffhanger that we end this meeting on, because it is now 5 Eastern and we are out of time.
Well, the reason I'm asking is because you wrote in there consensus on that. I'm not sure we have that yet because I'm not sure I understand what cascade delete means.
All right, cascade, whatever that is. How does that sound?
I'm agreeing to whatever that is. Okay.
Yes.
I'm not sure I agree with that, but okay, whatever. We can work with it.
Okay, we can talk in more detail about this aspect of unbind at a later time. But for now,
because to be honest, if we can't cleanly describe what the heck's going on under there, then I'm not sure we should even offer up this option. That's why I'm asking, but we can talk about it more later.
Agreed.
okay. I agree that it should be spelled out in more detail.
Yeah, you have to be able to reason about the state of the system once something is returned to you.
Okay. All right, we are out of time for now. Thanks, everybody. I will speak to you on the internet.
Okay.
Goodbye.
Bye.